All right, guys, so this is the graphing section. And the reason we have this specific section is because you are going to be asked to graph during the test. And I want to make sure that you guys are able to do that. And I know that we weren't really the best at graphing, so I want to work on that right now to make sure that we get it. So here's some simple questions. What goes into the x-axis? Now, something that we need to remember always is that in the x-axis, we go ahead and put our independent variable. Now, the next question goes along with that. It says, what goes into the y-axis? And for that, it's going to be our dependent variable. Now, here's the reason why we do that. We have to measure change whenever we do these graphs. You don't want your x to be the thing that fluctuates. See, you always put your independent variable on x because it has to be something consistent that does not change at the whim of anything else. So if you're measuring something and you're comparing it by time, you would put your time on the x-axis because time doesn't care about anything. It does its own thing. It's not affected by the results of anything. Another thing that you normally put on the x-axis would be something like temperature. Because again, most of the time, whenever we're looking at these things, these are independent variables. They're not affected by anything else. On the other hand, your y is going to be your dependent variable. It is 100% affected by your x-axis, by the thing that's in your x-axis. But we're going to work through an example, and you're going to see exactly what I mean by that in a minute. So here we go. A farmer wants to see if the amount of sunlight a plant receives will affect how much it grows. He creates 2 plots of land. The first plot only gets 6 hours of sunlight, while the second plot gets 12 hours of sunlight. I put sleep, but it should say sunlight. As a matter of fact, let's go ahead and correct that right now. Sunlight. He did his research for 10 weeks, and the data is shown in the table above. So we have the time, we have the growth on how much they grew per meter, and this was the group that got 6 hours of sunlight, and this is the group that got 12 hours of sunlight. So what is the independent variable in this problem? Okay, so let's actually look at it like this. We want to make sure that our independent variable is going to be our x-axis. Something is going to be consistent that doesn't change depending. So we are going to put time as our independent variable because look, as time goes, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, growth in meters cannot be our independent variable. And this is why. 0.5, 0.7, 0.9, 1.2, 1.4, 1.5, 1.5, 1.6, 1.5, 1.6. There was some fluctuation there. There was times where it actually went backwards. And then it started going forward again, and then it repeated the same number twice. And this is not a good consistent thing. See, our x-axis should be something that's going to continue going forward and forward and forward in a linear progression. Always and always, always going and going. Because time can continue going on, but the growth, that doesn't continue going on forever. And like we saw, sometimes it didn't grow as much. It actually regressed and grew less. But that's something that we can compare against time. So I'm going to make my independent variable time because it's consistent. Time is an independent variable. It's consistent. It's not affected by anybody else. It's my dependent variable. I'm going to put my dependent variable as my growth by meters. And the reason I'm doing that is because the growth that I have literally depends on the time. See, at 1 week, it was only 0.5 here. But at week 4, it was 1.2. And then at week 8, it was 1.6. So depending on what time I was measuring it, the growth number changed. Notice how the growth number changed depending on the time, but the time did not change depending on the growth. So the growth changed depending on the time, but the time did not change depending on the growth. Now that we have this, our independent variable, our x-axis is going to be time. Our dependent variable, our y-axis is going to be the growth in meters. Now we can go down, calculate the average growth of different plots. All right, this one's actually pretty simple. So all we got to do is add our numbers up together and divide by 10 because that's how many weeks we have. So we have 0.5. Let's actually pop up at a calculator real quick. Let's pop up a calculator. So my bad, guys. Calculator. It should pop up in a second. There we go. Really weird. Okay. Okay. So we got 0.5 plus. All right, guys. Well, that's not going to work. So I'm just going to go ahead and do it off of my phone. Sorry about that little wait that you guys are going to have to take. Now we have 0.5 plus 0.7 plus 0.9 plus 1.2 plus 1.4 plus 1.5 plus 1.5 plus 1.6 plus 1.5 plus 1.6. So our grand total is actually 12.4. So far from what I've gotten, it's 12.4, but now I got to divide it by 10. And our average growth for the plot at 6 hours of sunlight is 1.24. That's the average that I've gotten, 1.24. Now let's actually go ahead and do the 12 meters. And all I got to do for that one is, again, add all my numbers together. So 1 plus 1.3 plus 1.4 plus 1.6 plus 1.7 plus 1.8 plus 2 plus 2.1 plus 2.2 plus 2.3. And I'm going to divide that by 10. And our average number in this case was 1.74. So if we actually look at those numbers right here, the average for the different plots, my answer right now for this one is this. For plot 1, my average growth was 1.24 meters. For plot number 2, my average growth was 1.74 meters. That means 0.5 of a meter difference. That means if we actually look at that, on average, plot 2 grew 1.5 feet more than plot number 1 did. So the question comes down to this. Did the amount of exposure to sunlight affect the plant growth? I would say yes. I would say yes, because literally plot number 2 grew 1.5 feet more than plot number 1 did. But with that being said, guys, that is the end of this review. Please feel free to go ahead and contact me if you need any help. I am always here to help you guys. I want to help you guys as much as I can. And I really, 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 truthfully want you guys to do well on this exam. So feel free to contact me. I will be ready to join you guys in a Google Meet all the way up to 9 p.m. tonight. But anyway, guys, I love you guys very much. Do the best that you can on this exam. I know you'll do great. And I'll see you guys later. Bye, guys.